Hello, welcome to another 10Y Science lesson. Well done again for being online. Let's make a start then. We're going to be looking at radiation today. So our learning objective is to investigate the effect of surface coatings on radiation. And to do that, first thing we're going to need to do is explain how heat is transferred via radiation. We're then going to state the effects. So I'm not going to go into too much detail. We're going to look at the core knowledge of the effect of surface coatings on the rate of radiation. And we're then going to write a method for investigating the effect of coatings on the rate of radiation. So important, just with yesterday's lesson as well, up to 6 marks. Okay, this could be just core knowledge. They might package this into graphs and tables as well. Something we really need to be on. Key info again then, your submission will be pictures of all your completed work, just like yesterday, and you can pause or rewind the video to learn at your own pace. Don't worry if I'm speeding over things, just rewind it 10 seconds if you've missed a bit. Pause it if you want to have a read over the keywords a bit more. Let's get started on radiation then. So first thing, radiation transfers heat via electromagnetic infrared radiation. Now you might be thinking this isn't important. It is so important because it's how the sun heats the earth and the rest of the solar system, okay? And how stars in general, every solar system is heated via radiation. So I know you've been doing space with Miss Shearman, and that's how heat is radiated. Now, unlike conduction and convection, radiation does not need particles for the transfer of heat. Okay, so there's no vibrations here, there's no currents. It's literally just electromagnetic infrared radiation or electromagnetic waves. Now this means it can transfer heat in a vacuum. That's got nothing to do with a vacuum cleaner. Okay, a vacuum is an area with no particles. So I'm thinking of somewhere like space. Okay, space has got no particles. So only radiation can go through a vacuum. Only radiation can go through space. Now, something that's really important to know is that surface coatings or colours, which is a nice way, affect radiation. And we've got some key terms first which we need to know about. Absorb means take in heat. So if something is absorbing heat, it's going to get hotter. And if something is emitting heat, that means it is releasing heat or it is cooling. It is letting heat out. And we need to know the effects of 4 surface coatings on this. Okay, so my first one is a dull, matte or rough surface. So if it's matte, just means it's not shiny. Okay, now something which isn't shiny is very good at absorbing heat. It will heat up very quickly. And it will also emit heat very quickly. Okay, so we've got 2 things there. Something which is shiny. So I've got a tin can over here. This shiny tin can. It's going to be very poor at absorbing heat. But it's also going to be very poor at emitting it. Okay, now what I want you to think of, on a shiny can, light bounces off. That's what makes it shiny. So the reason it's not good at absorbing heat is because the heat literally bounces off. Okay, it cannot be absorbed by that. We then got something which is light coloured and dark coloured we're going to look at now. So a light coloured one is a poor absorber. Okay, it doesn't heat up very quickly, and it's also a poor emitter. And on the flip side, a dark coloured is the complete opposite. It's good at absorbing and it's good at emitting. Now I want you to think of, perhaps in the summertime, I know it's cold at the moment, in the summertime, if you go out perhaps wearing black jeans and a black t-shirt, that's going to absorb a lot of heat. You're going to feel quite warm. Okay, so that's why you maybe wear a white t-shirt, okay, because that doesn't absorb as much of the heat from the sun, as much of the radiation from the sun. Now, if you want to pause it right now and draw that table in, that's a really good summary. In fact, I'm going to advise you, pause the video now, draw that table in, because we're going to need it for some questions. So here's some true or false questions. What I'd like you to do, please, you don't have to write out the sentences, you just need to tell me, is it true with a T or is it false with an F? So pause the video and answer these questions now. Right, some answers then. True or false? Radiation can take place in a vacuum. That is true. Radiation transfers heat via ultraviolet electromagnetic waves. That is false. It is infrared. Okay. Radiation needs particles. Question 3. False. Question 4. Black materials are good absorbers of heat. That is true. Shiny materials are poor emitters of heat. That is also true. And then 6 and 7. 6. A matte material will heat up more quickly than a shiny material. That is true. Matte are good absorbers. And then 7. Light coloured materials will emit more heat than a dark coloured material. That is false, and that is because light coloured materials are poor emitters. Okay, so there's your 7. Just as yesterday, if you've got a red pen, make sure we're ticking or correcting. If you haven't got a red pen, just make sure that you're ticking and correcting where appropriate. Okay, make sure you're getting them down correctly. So we've got our core knowledge in place now. We first know what radiation is. We also know how the different colours affect radiation. So we're now going to look at an experiment which investigates the effect. Okay, we're going to look at some data. Or not look at, we're going to gather some data. So I've got an investigation here to the effect of surface coatings on heat transferred by radiation. And I've got a diagram of the equipment on the right here. Okay, this is a very simple practical. I'll be able to show you it when we're back in school. There's also a video on the YouTube channel. Okay, conduction 338. Oh no, 338 energy transfers, sorry. But first thing I'm going to do, I'm going to wrap a thermometer in either black paper, which is on the left here, or silver foil on the right. So I'm going to give my material a different surface coating. I'm then going to place each thermometer 10 centimetres from a filament lamp. Now, the really important thing here, okay, it could be 20 centimetres, 30, 40, okay, it could be 1. But as I have to make sure that it is exactly the same, okay, either way, okay, so, and from a filament lamp, heat source. It could be a heater, okay, it doesn't necessarily have to be a lamp, but something which will give out heat and will give it out continuously at the same level. I don't want a heater that will turn up to maybe 100 joules and then suddenly it's down to 10 joules. I need to have consistency. So first thing, wrap each in black paper and silver foil. Place each thermometer 10 centimetres from a filament lamp. I'm then going to get a stopwatch, okay? And I'm going to record the temperature of the thermometer every minute for 10 minutes, okay? So this is a practical where it's quite slow, but we need to be on top of, right, I'm going to go 1 minute, 2 minute, 3 minute, and I'm going to do that for 10 minutes. Now, variables. We have actually got 2 independent variables in this one because I am changing, as a scientist, 2 things. The first thing, which is quite obvious, I'm changing the covering of my thermometer, and I'm choosing whether it is either covered in black paper or covered in silver foil. But the other thing I'm choosing to change is the time. I'm deciding that I'm going to measure the time every minute for 10 minutes. So that's also an independent variable. My dependent variable, the thing that I'm choosing to measure, okay, the thing that I'm measuring, dependent variable, is the temperature of the thermometer, okay? So remember, dependent variable, what are you measuring? You're measuring the temperature every minute for 10 minutes. Control variables. My first thing, and we've spoken about this, I'm going to keep my distance between the thermometer and the heat source the same. I'm going to make sure it's 10 centimetres. I'm also going to keep the heat source the same. So this would be perhaps if I had 2 lamps, I would make sure that they're both the same brand and they've got the same bulb, okay? I need to make sure then that I'm not having a different lamp. Obviously, if I've got a really good heater, it's going to heat up one thermometer more quickly. I'm also not going to change my heat source at all throughout. I'm going to keep it the same the whole time. And I'm also going to keep the thickness of the wrapping the same. if you think, if I put a huge layer of black paper and a tiny thin layer of foil, it's likely that that black paper is actually going to mean that the thermometer heats up a little bit more slowly. It's a bit like putting a big coat on it, isn't it? So I'm going to make sure I got the thickness of the wrapping the same. And my prediction in this is that my thermometer wrapped in black paper will heat up more quickly, as black surfaces are good absorbers. So my black one is going to heat up more quickly than my silver one because it's going to absorb more heat. Remember, my silvery foil is a very poor absorber. My black paper is a very good absorber. Now, before you pause this video and make sure you've got this information down, because this is so important, I just want to let you know one inaccuracy. And our inaccuracy is based in human error of measuring the temperature. Okay, so to overcome that, I'm going to use a digital thermometer. Okay, I'm going to have something which will give me the reading. Okay, so it will give me, say, 21.2. There's no human error in me looking and trying to work out that temperature, because thermometers are sometimes quite tricky to get the exact temperature. So I'm going to use a digital thermometer, and the advantage is that there's no human error. So pause this video now, make sure you've got all that information down. It would be a good idea to have a drawing of it as well, because this is really key core information. Some questions then. Make sure you pause your video, have a good go at this, use your notes which you've just written down as well. And question 1 then, the thermometers are wrapped in black paper and silver foil. B, the time is measured using a stopwatch. And C, the heat source is a filament lamp. Question 2, explain what is important to A, keep the distance from the filament lamp the same, and that's because the closer thermometer will heat up quicker. Okay, so I need to have the same distance. And B, keep the thickness of the covering the same, and that is because thermometers wrapped in different amounts of covering will heat up at different speeds. So I've got to keep going that way. Question 3, give a reason why it would be better to use a digital thermometer. Well, that's I've got no human error. And then question 4, suggest how the experiment could be modified. Modified is a scientific way of saying changed, to investigate the effect of coloured paper on the rate of radiation. And my thing here is that instead of using black paper and foil, I'm going to wrap the thermometers in paper of different colours. So I could choose green and red, or I could choose grey and black. Any two colours are okay. Now remember to make sure to take a picture of every piece of paper that you've worked on today. Make sure you've got all of that work there and upload it onto Teams. Again, well done for attending this lesson, and hope you have a good rest of the day and rest of the week. Bye bye.